All right, we're going to take a look at an integration question here. We're looking at the integral of 1 over 1 plus tan of x with respect to x. And what we want to do here is take the integral of this. So first thing to do here, we're going to change the tan to sine over cos. Just get a better idea of what exactly this looks like. So this will be sine x over cos of x. Rewriting this with a common denominator here, you get cos of x over cos of x plus sine of x, and all of that with respect to x here. I'm going to go ahead and show you an interesting way this flows about here. I'm going to let I equal the actual integral we're being asked to solve here. So now we have that following. I've got I is equal to the integral of cos of x over cos of x plus sine of x. Now, I'm going to rewrite this as follows. I'm going to write this as negative sine of x plus cos of x over cos of x plus sine of x, plus the integral of, again, I inserted that negative sine of x into there, so I'm going to actually undo that by adding this to our equation. And now you'll see here, I've gotten rid of that sine of x, but by doing so, I've created an extra cos of x. I'm going to subtract off integral of cos of x plus sine of x here. So let me just rewrite this so you have a little more space. So now I have the integral we're trying to solve for, which we've kind of reduced, rewritten as the integral of cos of x over cos of x plus sine of x dx. I rewrote it as the following expression, these three terms here. The reason I did that is the derivative of the ln of cos of x plus sine of x is exactly going to be equal to 1 over cos of x sine of x. Then you chain rule kicks in, you end up getting this negative sine of x cos of x. So what I'm saying is this right here, the integral, this is going to end up being the ln of absolute value of cos of x plus sine of x. That kind of worked towards our favor here. I added this in just to cancel off the sine of x, so I didn't like change the question. And then I ended up creating a double cos of x, so I had to subtract one off. But what's interesting that happens here is, again, this is equal to I. We've actually got I showing up twice. You have this here as well. So I can bring this right here can be written, rewritten as just I, right? This whole expression is just equal to I. So when I bring both the i's to one side of the equation, we're going to get 2i equals. As we just talked about here, the integral of all of this with respect to x is exactly equal to the ln of the absolute value of cos of x plus sine of x. And this right here is essentially just asking you for the integral with respect to x, right? As that just simplifies to become 1. So now we end up having 2i is the ln of absolute value of cos of x plus sine of x, plus this ends up being x plus some constant term. And to finish this off here, we can go ahead and divide across by 2, giving me 1/2 the ln of the absolute value of cos of x plus sine of x, plus 1/2 x plus constant term c. Again, interesting trick here that happens. Just manipulating a bit, we end up getting that same integral on both sides of the equation, and we saw that happen right here. And when that happens, you can combine them together, as we did. I brought that over, I ended up getting 2i, and dividing across, isolating for I, we get our integral here. All right, thank you.